Now we are doing this question regarding remainder and the factor theorem for this question, where p of x is equal to minus 4x cubed plus ax square plus bx plus 2 has a factor x minus 1 and leaves a remainder 8 when divided by x plus 1. Find the value of a and b. Solve this p of x is equal to 0, where find why there is only one linear factor of p of x. So for this solution of this problem, we will first use the factor theorem, where x minus 1 is a factor. So p of x is basically equal to minus 4x cubed plus ax square plus bx plus 2. Now, there's x minus 1 is a factor. So you put x minus 1 equal to 0, then x will be equal to 1. So it should be minus 4 into 1 cube plus a into 1 square plus b into 1 plus 2, and that thing is equal to 0 because it is a factor of that. So this should be equal to minus 4 plus a plus b plus 2 equal to 0. This will become a plus b equal to minus 2, and this will go to the side, and it is 2 there. So a plus b is equal to 2 when it is has a factor x minus 1. Now it leaves a remainder equal to 8 when divided by x plus 1. So now you put x equal to minus 1 for this, and this should be equal to minus 4 into minus 1 cube plus a into minus 1 square plus b into minus 1 plus 2, and that should be equal to 8 because it is leaving a remainder equal to 8 there. So this will become 4 plus a minus b plus 2 is equal to 8, or a minus b is equal to 2 there, and let's say that is equation number 2. Now we solve 1 and 2 there simultaneously. Signs are already opposite. This and this cancel out. So 2a is equal to 4, or a is equal to 2. Now we put a value of a in any one of this equation. A minus b is equal to 2. 2 minus b is equal to 2. So b is equal to 0. So a is equal to 2 and b is equal to 0 is the first value we have calculated there. Now we write this p of x is equal to minus 4x cubed plus 2x square plus 2, and that thing is equal to 0 because we are using the factor theorem for this p of x is equal to 0 to solve it. Already we have calculated that x minus 1 is a factor, so we use the identity method for this equation there. Minus 4x cubed plus 2x square plus 2 is identical to x minus 1 is a factor there, and then the remaining part will be a quadratic equation there. Now this is ax cube plus bx square plus cx multiplied in each other minus ax square minus bx minus c. Let's say that is equation number 3. Now compare the coefficient of x cube on both sides of this equation number 3. The left hand side has the coefficient minus 4, and the right hand side has the a. So a is equal to -4 for this portion. Then comparing the coefficient of x square on both sides, the left side of this one is x square coefficient is 2 there, and the right side is equal to b and a there. So b minus a. So b is equal to a plus 2. A value is equal to -4 plus 2, and that value is equal to -2 there. Then comparing the coefficient of x on both sides, here the coefficient of x on the left side is 0 there, and on the right side the coefficient of this one is b and c. So c minus b there. This implies that c is equal to b, and b value is already equal to -2 there. So this equation will become minus 4x cubed plus 2x square plus 2 is identical to x minus 1 into a value is there -4 x square, b value is there -2 x, and c value is there equal to -2, and that thing should be equal to 0. Then we can write this thing as x minus 1. Minus 1 is common there. 4x square plus 2x plus 2 equal to 0. This thing should be equal to x minus 1 into 4x square plus 2x plus 2 equal to 0. If we take 2 as common there, x minus 1, 2, 2x square plus x plus 1 equal to 0. Then this should be equal to x minus 1, 2x square plus x plus 1 equal to 0. Now, you have to show it that there is only one linear factor, because this factor, which is 2x square plus x plus 1, is not solvable. Because b square minus 4ac for this portion is 1 square minus 4 into 2 into 1, and that is equal to 1 minus 8 minus 7, which is less than 0. So this quadratic equation cannot be solvable there. So we have shown it there that there is only one linear factor in this part, that is x minus 1, and the other part of that equation is a quadratic form of that thing there. Now you have to recheck this answer with the help of this discrete rule there. Since there are total 3 roots possible, they can be real, they can be imaginary, or they can be positive and the negative. For this positive value, p of x is equal to, because that thing is being calculated there, it is -2 plus, there is one sign of change there, and +2 plus, there is no sign of change there. So there is one positive factor of this real factor there. Then you will check the negative values to that. So we can replace it like this. P of minus x is equal to, this will become 4x cubed plus 2x square as it is plus 2. There is no change of sign in this part, there is no change of sign in this part. So there is 0 negative real root there. Total roots are 3. So the 2 roots are imaginary in this case there. And we have seen it here that there are only 2 roots imaginary, because this quadratic equation is not solvable for that part there. So this is a complete solution of this problem where first you have to find out the values of A and B with the remainder and the factor theorem. Then you will solve it, and then you have to check the roots. And there is one real root, positive in this case, and the two roots are imaginary.